Hello everyone. In our previous lecture, we did a numerical or example for calculating the inductance of a composite conductor. Now, we will see how to use the tables given by manufacturer for calculating the inductance of a conductor. Usually, the manufacturer provides us the geometrical mean radius of the conductor as well as two other factors. Before that, going to that, let us see how to calculate the reactance if an inductance is given. As we already know from circuit theory that if L is the inductance, then the reactance is simply omega L or j omega L. We are not showing the j part here since we are only interested in the numerical part. So XL is equal to omega L, or omega is written as 2 pi f. It is then 2 pi f L. Now, as we already know that the inductance of a composite conductor is written as 2 into 10 to the power minus 7 natural log dm upon ds, where dm is GMD, that is geometrical mean distance, and ds is geometrical mean radius. I can bifurcate this logarithmic term in two parts, one by ds and other is dm, and I can write it in this way. Now, when I multiply the inductance with omega, I get these two terms. Usually, in India, manufacturer provide these two terms at frequency of 50 Hz. This first term, as you can see, is simply the inductive reactance when dm, that is the spacing between the two identical conductors, is 1 meter. Given that this ds is being measured in meter, if it is being measured in feet, then I will write XA as inductive reactance between two identical conductors 1 feet apart if ds is in feet. If ds is in meter, then I will use it as inductive reactance between two identical conductors which are 1 meter apart. As I already shown here that there are two identical conductors with radius r and at a distance of d meter, then Lx can be simply written as d by r dash, natural log d by r dash. If d is 1, it simply comes out to be Lx is equal to 2 into 10 to the power minus 7 natural log 1 by r dash. R dash is nothing, simply ds, the geometric mean radius. The other term xd is known as inductive reactance spacing factor. When we are given that the conductors are, let us say, x meter apart, then this thing comes into play. As we already know, we have already seen also that this dm does not depend upon the type of conductor. And also, if the distance between conductors is very large as compared to their own radius, then it only depends upon the distance between the two conductors. So, this spacing factor dm or the GMD only depends upon the distance between two conductors. So, it is very easy to separately write it. And the manufacturer usually gives standard values for, let us say, for standard spacing, let us say 1 meter, 2 meter, or if we are talking in feet, they give us values at 20 feet distance, 10 feet distance. Similarly, from tables, I can find these two values and directly write the inductance. Let us say I have been given for some conductor, let us say X conductor, this XC is given, let us say 0.7 Henry, and this is also given, let us say that the conductors of that transmission line are 20 meter apart, and because of that this factor is also given, let us say 0.8, then the total inductance of that conductor will be simply 1.5 Henry per meter, or whatever the units these are in. So in this way we can simply use the two values usually given by manufacturer in their tables. In this way, we do not need to calculate separately GMR or GMD for the conductor configuration. Usually it is being given by the manufacturers for typical or the standard configurations and spacings. Thank you. One more request, if you find my lectures helpful or interesting, then I request you to subscribe my channel and share it with your friends also, so that they can also log in and watch the videos. Also press the bell icon so that you can get the notification for the new videos as and when they are uploaded at the channel. Thank you.